Unit 2, Part 2. Covered in this video, solving a quadratic formula and completing the square, finding the discriminant and describing the solutions, simplifying expressions involving complex numbers, finding zeros of a polynomial, the sum and product rule, and writing an equation for a polynomial given rational and imaginary roots. Solving a quadratic by quadratic formula, the quadratic formula is opposite of b plus or minus the square root of b squared minus 4ac over 2a.
The quadratic formula example is 9x squared plus 6x plus 1 equals 0. 9 would be a, 6 would be b, and 1 would be c. X equals the opposite of b, so negative 6, plus or minus the square root of 6 squared minus 4 times 9 times 1 over 2 times 9, which would simplify to negative 6 plus or minus 0 over 18. X would then equal negative 1/3.
Completing the square, x squared minus 10x equals negative 16. For this equation, we need to plus 25 both sides of the equation. So we factor the left side, get x minus 5 squared, and the right side equal 9. And then we square root both sides. We can get x minus 5 equals 3, and x equals 3 plus 5, x equals 8. How to find discriminant and discrete solutions? If answer is positive, the number, and is not a perfect square, it has two real irrational roots. If answer is positive number and is a perfect square, it has two real rational roots. If answer is negative number, it has two imaginary roots. When the answer is 0, it only has one real rational.
Simplifying expressions involving complex numbers. When you're adding an expression with complex numbers, you must carry out the I if the square root is negative. So for adding, this would be I over square root of 9, and the square root of 9 is 3, so it would be plus or minus 3i. And the square root of negative 25 would be I over square root of 25, and we know the square root of 25 is 5i, so it would be plus or minus 3i plus or minus 5i, which would get you plus or minus 8i. When subtracting, you do the same thing. 10 plus 3i minus 2 minus plus or minus 5i. 8 minus plus or minus 2i, 8 plus 2i. When multiplying, 8 times 4i times negative 9i. You know I is the square root of negative 1, so once you multiply, you'll get 8i times negative 36i squared, which you know is also 36. So 8i times 36, and that would be negative 288i. Dividing 6 plus 3i over 7 minus 5i, you would then find the conjugate of 7 minus 5 of the denominator, so 7 minus 5i, and multiply the entire equation by that. And then once you do that, you'll get 6 plus 3i over 7 minus 5i times 7 plus 5i over 7 plus 5i, which will then get you 42 plus 30i plus 21i plus 15i squared over 49 plus 35i minus 35i minus 25i squared. Simplifying into 42 plus 51i plus negative 15 over 49 plus 25, which will finally get you 27 plus 51i over 74. How to find all zeros of a polynomial using synthetic division. When using synthetic division to divide, usually a factor will be given to you. In this scenario, 3x cubed minus 4x squared plus 2x minus 1, and dividing it by x plus 1, set x equal to 0 to get negative 1. Then use the first number of each equation and place it on a placeholder. And then drag down the first number, which usually has the largest square, and then drag it down and multiply it by the thing that you set x equal to, so in this case negative 1. So drag 3 down in this problem, and it would be 3 times negative 1, which would get, then you would add along. So negative 4 plus negative 3, negative 7. Multiply negative 7 by negative 1 to get you 7. 2 plus 7 to get you 9. 9 times negative 1. Negative 1 plus negative 9 equals negative 10. Negative 10 in this problem is our remainder, so we would set our equation up like that. 3x squared minus 7x plus 9 minus 10 over x plus 1.
Using synthetic division to divide imaginary numbers. For this problem, our example is x to the fifth minus 6x to the fourth plus 11x cubed minus x squared minus 14x plus 5. The divisor is 2 minus I. 2 minus I would go over here, and you would multiply. You would drag down the 1 first, and 1 times 2 minus I would be 2 minus I. Negative 6 plus 2 minus I would be negative 4 minus I. Negative 4 minus I times 2 minus I is negative 9 plus 2I. Negative 9 plus 2I plus 11 is 2 plus 2I. You would do that for the whole row. After you're done getting the answers for the first row, you would divide all that by 2 plus I to get rid of the imaginary numbers. You would drag down the 1, and then you would add 2 plus I to negative 4 minus I to get negative 2. Then you would multiply negative 2 times 2 plus I to get negative 4 minus 2I, which you would add to 2 plus 2I to get negative 2. You would do that for the whole row until you had no imaginary numbers left. After that, you would divide it again by another number. For this one, we chose negative 1. We would drag down the 1. We would multiply the 1 by negative 1 to get negative 1. Negative 2 plus negative 1 is negative 3. Negative 3 times negative 1 is 3. 3 plus negative 2 is 1. And then 1 times negative 1 is negative 1. So 1 plus negative 1 is 0. 0 is our remainder, so it would be x squared minus 3x plus 1. After that, you would do the quadratic formula to find the other solutions for that problem. So x equals 3 plus or minus the square root of 9 minus 4 times 1 would be over 2. That would simplify to x equals 3 plus or minus the square root of 5 over 2. The solutions for this problem would be x equals 2 plus or minus I, x equals 3 plus or minus the square root of 5 over 2, and x equals negative 1.
Finding all zeros using the quadratic formula. So for this problem, a factor wasn't given to us, so we'll use our calculator to find the factor of x to the fourth minus 3x cubed plus 64x minus 192. Notice in this problem there is no x squared, so we must put a placeholder in it when using synthetic division. So in this problem, we have 3 we find x minus 3 to be our factor, so our factor would be 3. And then we drag down the 1, multiply it by 3, add across, and get 0, and then multiply 0 times 3 to get 0, and then multiply 0 times 3 again, and add it to 64, which will get you 64, and then multiply 64 times 3, which will get you 192, and the 192s will cancel out. So our remaining equation is x cubed minus 64, and then that's when we would do first one, second one, first one squared, product of the two, and the last one squared. And using that separate equation, x squared minus 4x plus 16, we'll plug it into the quadratic formula. So opposite of b, 4, plus or minus 4 squared, which would be 16, minus 4 times 16 times 1, which would get you 16 minus 64, and the square root of that over 2. So 4 plus or minus the square root of negative 48 over 4. So factors that go into negative 48, to rationalize it, would be 4 plus or minus 4i, because you're carrying out the negative, over 3 over 4 times the square root of 3 over 4, which would simplify to 1 plus or minus I over the square root of 3. How to find all zeros of a polynomial by factoring. Factoring is very simple, and you just find factors of 12 to equal 8, and the factors would equal x plus 6, x plus 2, and then you'll set those factors equal to 0, which would be x equals negative 6 or negative 2. The sum and product rule for complex roots. The rules are to write the conjugate pair of zeros, find the sum of zeros, find the product of zeros, and the rule is x squared minus sum of x plus the product. So in this example, given the factors x plus 5 and x minus 2 plus I, find the polynomial. So we know that the 2 plus I and 2 negative I are conjugates, so we know the sum of those. The i's would cancel out because one is negative and one is positive, so the sum would be 4, and the product would be 5, because 2 minus I and 2 plus I would give you negative I squared plus 4, and then you would just add plus 1. So the equation is, using the rule, x squared minus 4x plus 5. And then use the box method using the other x that was given, so x plus 5 and use the box method to multiply x squared minus 4x plus 5 times x plus 5, which will get you x cubed plus x squared minus 15x plus 25.
Equation for a polynomial given rational roots. So for this problem, we are given 2, 5, and negative 4, and we have to make our own equation. So first, we do x minus 2, x minus 5, and x plus 4. We do the opposites. So we multiply x minus 2 times x plus 5 to get x squared minus 7 plus 10. We multiply that by x plus 4. We multiply the whole thing and get x cubed plus 4x squared minus 7x minus 28 plus 10x plus 40. We would simplify all of that to x cubed plus 4x squared plus 3x plus 12. That is our answer. Equation for a polynomial given imaginary roots.
Our example is given the root of 4i and 3. So we get the y equal x plus 4i times x minus 4i and times x minus 3. And we multiple of them get the x squared plus 16 times x minus 3, and then get the equation of x cubed minus 3x squared plus 16x minus 48.
In this video, you should know how to solve quadratics using the quadratic formula and completing the square, how to find the discriminant and describing the solutions, simplifying expressions using complex numbers, how to find factors of a polynomial using synthetic division, quadratic formula, or by factoring, the sum and product theorem for complex roots, and writing an equation for a polynomial given rational and imaginary roots. So our examples.